Weld flaws are discontinuities or imperfections that reduce the strength, durability, or appearance of a welded junction. These flaws might appear on the surface, within the weld, or in the heat-affected zone. HAZ. Porosity. Small gas pockets or cavities formed inside or on the surface of the weld bead. Cause contaminated surfaces, insufficient shielding gas coverage, or moisture in consumables. Solution: clean surfaces, ensure appropriate gas flow, and store consumables properly. Cracks. Cracks are cracks or separations in the welded joint that can occur on the surface, in the weld metal, or in the heat-affected zone. HAZ. Hot cracks arise after solidification, while cold fractures emerge after cooling. Excessive stress, quick cooling, incorrect welding methods, or high hydrogen levels are all potential causes. Solution: use preheating, controlled cooling, and low hydrogen electrodes. Decrease residual stress using post-weld heat treatment. Undercut. A groove or depression along the weld toe weakens the joint. Cause excessive welding current, an incorrect electrode angle, or a fast travel speed. Solution: set proper welding parameters, manage travel speed, and adjust electrode angles. Incomplete fusion. Description: the weld metal fails to fuse properly with the base metal or between multiple weld passes. Cause low welding temperature, improper welding angle, or contamination on the joint. Solution: increase welding current, maintain proper angle and torch control, and clean the joint. Incomplete penetration. Description: the weld does not penetrate the entire thickness of the joint, leaving unbonded portions. Cause inadequate heat input, poor joint design, or insufficient electrode manipulation. Solution: increase heat input, employ correct joint preparation, and modify welding procedures. Slag inclusion. Description: non-metallic particles, slag, become stuck in the weld, inhibiting complete fusion. Cause poor slag removal between passes, insufficient heat input, or poor welding technique. Solution: remove slag between passes, increase heat input, and apply proper torch manipulation.
Overlapping. Excessive molten metal flows past the joint edges, resulting in an overlap without fusion. Cause inadequate travel speed, high welding current, or incorrect electrode angle. Solution: reduce current, manage travel speed, and modify the torch angle.
Burn through. Description: the weld metal melts through the base metal, leaving a hole. Cause high heat input or a thin foundation material. Solution: for thin materials, use appropriate welding conditions and back shielding procedures. Distortion, warpage. The welded portion warped or deformed as a result of uneven heating and cooling. Cause excessive heat input, inadequate clamping, or incorrect sequencing. Solution: use clamps and fixtures, regulate heat input, and perform backstep welding or staggered welds. Spatter. Small metal droplets scatter and harden around the weld region, minimizing its appearance. Excessive current, a long arc length, or inadequate gas shielding are all possible causes. Solution: modify welding parameters, keep a suitable arc length, and optimize shielding gas flow. Weld bead irregularity. The weld bead seems uneven, having different widths and heights along the joint. Causes include poor torch control, fluctuating travel speed, and irregular electrode feeding. Solution: keep a constant travel speed, employ suitable torch angles, and ensure consistent electrode feeding. Root concavity. The weld root surface sinks inward, resulting in decreased strength at the root area. Cause insufficient root pass heat, poor root gap fit up, or incorrect welding parameters. Solution: modify heat input, guarantee correct root spacing, and monitor root pass technique. Root undercut. Description: insufficient filling causes a groove to emerge at the weld root, weakening the joint. Cause excessive current, faulty electrode manipulation, or incorrect root gap preparation. Solution: use proper current settings, follow a consistent welding method, and properly prepare joints. Excessive reinforcement. The weld metal protrudes significantly above the surface of the base metal, resulting in a stress concentration point. Cause slow travel speed, too much filler material, or insufficient torch control. Solution: change the travel speed, use the appropriate filler material volume, and keep control of the arc. Hot tearing, solidification, cracking. Cracks form as the weld metal cools and hardens, typically along the center line. Cause insufficient weld metal ductility, excessive heat input, or thermal stress. Solution: reduce heat input, employ preheating, and choose filler materials with high ductility. Lamellar tearing. Description: cracks form in the base metal parallel to the weld due to non-metallic inclusions or poor material quality. Cause high stress perpendicular to the grain: use of low-quality steel or improper joint design. Solution: use high-quality steel, modify joint design to reduce stress, and employ multi-pass welding. Weld metal contamination. Description: foreign material like as dirt or grease becomes caught in the weld and weakens it. Causes include improper workpiece cleaning or the use of contaminated filler materials. Solution: prior to welding, carefully clean all surfaces and consumables. Arc strike, arc burn. Unintended arc interactions outside the weld area produce localized damage such as cracks or metal weakening. Cause unintentional electrode contact or faulty arc start. Solution: use correct arc starting techniques and avoid making unwanted contact with the base material. Misalignment, mismatch. Description: welded parts are not properly aligned, resulting in weaker joints and poor fit. Cause insufficient fixturing or improper joint preparation. Solution: before welding, use correct clamps and fixtures and ensure that the connection is accurately aligned. Blowholes. Large gas pockets form within the weld, usually due to trapped air or moisture. Cause inadequate gas shielding, tainted materials, or excessive cooling. Solution: ensure adequate shielding gas coverage and utilize preheating to remove moisture.